Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Hi, I'm Dr. Elizabeth Cook, your host of the Grid Mod Pod and Vice President of Technical Strategy at AEIC. On today's episode, I discuss one of the most critical and least visible systems holding the modern grid together. It's back, telecommunications. I'm joined again by Francis Frank. He's the executive consultant for Grid Modernization at Bahamas Power and Light. For decades, Telecom sat quietly in the background. If the light stayed on, most people never thought about the communication network. But that network carries the protection signals, the operational data, the field communication, the SCADA traffic, everything operators rely on to see and run the grid. Francis and I get into why it stays invisible, why that's both good and dangerous, and what happens when the transport layer and the control layer fall out of sync. This one really comes down to people and alignment, not just technology. As the grid interconnects more devices and more real-time data, telecom is becoming the connective tissue, the nervous system that holds everything together. We hope you walk away from this podcast with the insights and momentum needed to spark change in our industry. Welcome back to the Grid Mod Pod. Today, we're diving into, I believe, one of the most critical and, as I mentioned before, least visible systems supporting modern grid operations. So we're back again with Francis Frank to talk about telecommunication infrastructure and a little bit more of a deeper dive. But for decades, telecom sat quietly in the background. If the light stayed on, most people never thought about the communication network, let alone the grid. But to those that don't understand, the communication network is carrying the protection signals. It transmits the operational data, the field communication, something called SCADA, the traffic of like what's happening at the asset and what the operators can see. So now, increasingly massive amounts of real-time intelligence is becoming available to all end users and operators of the grid. So today, Francis, thank you for joining me for another enlightened conversation about telecom.
You're welcome. It's always an honor, always a pleasure to have these conversations with you because, funny it is, although I share my knowledge, I learn something based on the feedback from the viewers. So I'm really looking forward to another great episode.
Love it. And I guess, since you and I know each other, but maybe there's a new listener. Why don't you give them an introduction of who you are?
So I'm Francis Frank. I'm currently the executive consultant for Grid Modernization at the Bahamas Power and Light. So if you're in the Bahamas, say hello. So there I advise the utility and in some instances the government on all of the new technology, how we're going to tie these new technologies into the grid. The Bahamas is going through a period where they call the new energy era, and it's a $1.75 billion program where they're revolutionizing the grid, getting solar, batteries. We're also changing from diesel to LNG, liquefied natural gas, bringing new power lines in, bringing in new gas lines in. It's an amazing time to be a utility professional in the Bahamas. And that is going to set the stage for not just the Bahamas, in my opinion, but in these islanded systems and in these developing countries like the Caribbean, these other islands, this could be a template that could be used for the path forward. So we have SCADA, a brand new SCADA system. We have a new AMI system going, advanced metering infrastructure. We have a new GIS system, geographical information system. We have, when you look at getting to know what is happening, as you always say, full situational awareness.
Yes.
That's me in a nutshell.
I guess I have to share, and from like you and I in really this grid modernization space, and really the power of understanding the importance of the knowledge of one is the knowledge of all, which is truthfully the byline of AEICs for 140 years. And so as I continue to sit in the seat with AEIC and having this amazing opportunity to talk to all these leaders, you and I cross paths. And I remember being told 20 years ago during a coffee break when I worked at MEPI to remember to pick up the phone. And also, the power industry is a small industry. But to our listeners, Francis and I crossed paths at a utility that we worked for, where I was his system planning leader when he was the grid mod director, and then I became his successor when he moved on to bigger and greater things. And just realizing, the importance and the value of having a network of those that understand the dynamics of what occurs within a utility space, because it's nothing that is taught, especially in our education system, let alone our college and universities, of what the utility is from an interworking perspective. Because you have a regulatory arm, you have the financial arm, and then you have the operations arm. And so we've created this machine over 140 years that's actually multiple machines. So when I talk about the invisible part, the network, or the communication, is even another layer of you have to really desire to lean in and dig in to be taught, no matter where you sit in the utility, of what is this grid that transmits all of this information that a lot of us, even when we're working in the utility, don't understand the complexities of the data that we did have access to. Anyway, so I just feel like full circle. I love that I can bring you on here and we can talk about one of the mysteries, which is telecom. The purpose of this discussion is really bring it to light. Is that a pun? I don't know.
Yeah, I mean, I always thank you for the opportunity, as I said before, and your mentorship, right? Because, the industry is small, and, most of the key players, we all know them. We go to the same conferences, we read the same white papers. So it's a very small industry. But the mentorship, the ability to pick up the phone and say, hey, I have this problem. Have you seen that before? Really brings the everything along. So,
and not to I don't know. But I would just say it's, and I think I've been saying this quite a bit, it's not really about the technology right now. We're all talking about the technology and the infrastructure. It really comes down to the people who carry the work,
definitely.
The relationships that form across functions, which is my, goal in life, is de-siloing the silos and really just creating a space where shared understandings develop into the empowerment for you as an individual leader sitting within the Bahamas state, and me sitting here amongst utility leaders, and each individual utility leader that we get to speak with, that there's this commonality. So I'm excited to dive in. So should I softball you? Francis asked me for some questions, but here they are. Here's the first one. Why, I think I did that to you one other time you're here, why are telecom systems still so invisible despite being absolutely critical to the grid operations? So let's start there.
That is one of the great ironies of industrial engineering, right? Because when you look at the telecommunication, if it's working properly, nobody cares about it, which is good and which is bad at the same time. So we have a lot of reasoning for that. So let's start with the physical and functional concealment of that. On most transmission poles that you see, there are telecommunication lines there, like the OGW cable and stuff like that.
Whoa, you can't wait. You can't do an acronym without saying what it is.
Optical ground wire. Okay.
Yeah.
Which is fiber optic cables. But to the layman, to the layperson, it just looked like a regular transmission cable. And they don't even realize that that is actually the communication cable. that is a part of this of pole or this infrastructure. So the physical concealment is one of them, right? The reliability of it. Most control systems are built to what they call the five nines. 99.999%. You got to be that reliable.
That's pretty reliable.
And with that, since they're usually on the communication end, usually little or no failure is usually overlooked. And finally, when you look at control systems like SCADA, like ADMS, and the lights, if you're not in the industry, you might hear the word and that's all you do. You hear the word or you hear these acronyms, right?
It's like a point in time. You just hear the word and you move on.
Right. So because it's not in your day to day, most of the lay people don't even realize the relevance or the significance of telecommunication to the modern grid today. And I want to stress the modern grid, right? Not the traditional grid where you have a big plant and a passive customer. This is now everything interconnected, where data at every function and every stage is so important. And finally, even in the industry, when you look at a substation, when you go into a substation, the communication equipment are usually housed right next to your protective relays. They're housed near to your RTU, which is remote terminal units. So to somebody who's also new to the industry, to them, they might think everything is one system. Or sometimes the communication system are just tucked away in a corner anyway. If they're not close to the rack, they're tucked away behind some great cabinet that it's in there. It's like, don't touch that. That's for some other guys, right? So that concealment really and truly is aiding
Like,
that invisibility that you
it's
question.
actually being hidden.
Right.
And I guess, from my own experience, coming into the utility, your transmission planning manager, there's a whole series of NERC standards and SIP standards, aka requirements that we as an industry have drafted to ensure if an entity is deemed a transmission owner, such as also a generation owner, there's a certain set of requirements. And actually, knowing what I knew from a system planning, integration of the physical assets of the grid, I remember going into a substation, just like you stated, and my job was to really understand what actual pieces of devices needed to be understood and really accounted for, like from a physical, like, yes, that's here. Yes, it's in my document. Yes, that's here. Yes, in my document. But a big part of those standards was a lot of the controls and the communications that are sitting within your control center hubs or your control buildings that are on site inside a substation fence. And I didn't know. I kind of knew it from like a one-line drawing, I guess, but not what it actually looked like. And it's actually quite underwhelming. No, I'm just kidding. Compared to the massive, circuit breakers or transformers, it's a box that's connected with a lot of information.
That thing there, right?
It's like, when you walk down into your basement and you find your router that has a one port. Now this is a much, right? But there's like so much happening there.
Exactly.
Okay, so what I heard is also, and I guess just to lean in on an episode that I talked with a team, I loved it. They were actually, there's 4 of them. They wanted to be on the podcast because they were all a part of a very large project of their radio, the land radio replacement. Mm-hmm. And it was a 10-year journey. And they successfully completed it. And it was just like, again, this whole telecom project management execution space. But like a big part of it was, if SCADA worked and everything moved, we were good. But they were replacing technology for like, well, if there is an event such as Storm Helene, you know, you as a group of people that need to maintain the operation of the grid need to be able to still communicate. So there's like segments of various communication mechanisms, I guess, that are even a layer deep. So like SCADA's like, everyone knows about SCADA, but then there's like these other systems to keep the whole communication network intact. Anyway, I diverge. So what is happening is more or less this modern grid, which you mentioned, is exponentially interconnecting more devices that have different dynamic data streams. So it's even ever more. And so I guess for any analogists out there, it's like the connective tissue. What's that thing? Oh my gosh, my mother. The fascia, you know, the whole sheath that like goes over your body that like keeps it all together. I said the wrong word. What is it, Francis?
I don't even know the right word, so.
SCIA. Anyway, or it's the nervous system.
Nervous system. I know that.
Okay, so here's my other question. And I guess we already kind of spoke to it. So this is just your opportunity to just go a little bit deeper. And the questions here, listener, is really to keep us focused because this is a very big topic. So ready? And also, you didn't realize you're about to be educated. So you're about to be, what's the word, Francis? We can cut this out.
Anybody you say they will believe and agree. So I'm good.
Okay.
I'm answering questions.
I know, but don't worry, we'll edit this. I really need the word. You didn't know that you were going to be informed.
Enlightened.
Taught. You didn't know. Here, wait. I'm going to pause. This is what we're going to say. You didn't know you're going to get Professor Cook and Professor Frank here today. But let's dive in deep.
I like that.
How is the modern grid, in your own words, becoming increasingly dependent on the communication infrastructure?
That's another great question. So I describe it as the changing relationship between electrons and bytes, right? So electrons from the electricity itself, but bytes measuring the data. And that's because of two-way power flow, for example. I mentioned before we had one centralized generation plant, passive end user, and we just send electrons down the street, across the transmission line, across the distribution line, into your facility, and that's it. But now we have distributed energy resources where we have, and so the grid is changing, generation is changing. When you look at solar and battery, and you still have your thermal engines, your traditional generation plants, but along the path from the traditional generation plant, you have so much injection of power from all of these distributed energy resources. So that is one. Two, the need for things like phasor measurement units, PMUs. Some of these phasor measurement units sometimes communicate, sometimes 30 to 100 times per second.
Think about that. That's like faster than blinking.
Think about that, right? And then last but not least is the real time. You need real time data to make real time decisions. So you have an outage that is planned. It's very easy, right? We know we're going to de-energize this piece of equipment and we're going to do the repairs and return it to normal state. But when you have an unplanned outage, somebody driving down the street and run into a pole and cause an outage in your neighborhood or down your street, you need the communication to, one, relate that sometime before you get the call from your operations or your emergency management services. So you, from a safety perspective, can turn off any live device or energized piece of equipment. So it's becoming more and more dependent for so much different things. Operationally, from a safety perspective, and finally, because of the injection of this bidirectional power flow that continues to revolutionize and modernize the grid that we knew 50 years ago, probably sometime 30 years ago. Because what as these distributed energy resources becomes more efficient, we continue to use them because not just from an efficiency perspective, but the cost is also being reduced in terms of procurement. So now I'm buying something that is cheaper, and I'm also is the efficiency have improved, so I could depend on it more. The solar stores the power in the day, the battery distributed in the night, things like that. But you need to know all of that, and all of that is your communication behind the scenes that enables that. And as I said before, it's very easy to, because of the invisibility of it, if it's working, it's working, but it's equally as important.
And, I think what's happening, and really just kind of layering on what you said, is utilities have really been moving in an isolated operational technologies space towards now this deeply integrated ecosystem.
Mm-hmm.
So, historically, we've been very siloed for the reasons being that technology could be siloed because it operated within a space, rinse and repeat. As we've deployed field devices, so before, this is our little history lesson, I think it's always nice to be reminded that the communication system was being built and designed at the same time the electric power grid was. So when you had substations created, it was just two men with phone calls through this brand new thing called the phone system. I don't think it was called that, but you know what I mean. I think it was called the telecom system. But, right. And then as we've deployed field devices over time, they start communicating. And then, as you mentioned, the distribution energy resources, they start communicating. And sensors in general are feeding all of this analytical platforms that we all talk about. And I'm genericizing it just to not say this is full, right? It's important because words matter. But so Operations Center became from just a couple phone calls and scattered substations to now an enormous amount of automated devices sending information. And I guess I just wanted to make the point again and again, because I don't think we're speaking about it enough, is, this space that we're in, most organizations think about modernization as deploying individual technologies instead of truly understanding this full operational ecosystem that's required to support the technologies that we speak of.
Right.
So not to labor a list, but right, we're really, when you're a telecom specialist, Francis, right, knowing what you are the SME of communications, but you have to know a little bit about this cybersecurity space, because of course everyone's going to talk about that. You really have to understand the whole field process, end to end of what's happening. Then you have to understand what is, and we didn't really have this term before this world that we live in, but data governance, the importance and the value of having the information correct, because as you said, it has to be 99.9999, I don't know if you use that many nines, % reliable, which is the part you have to have operational trust. So then you, as an individual that's in charge of all of these systems, have to believe that the other systems that are operating are doing their job. And then it all has to interconnect, which is called interoperability, people. So, and I guess at the core of it is a telecom SME. I mean, they need to be in the room, and they need to be listening, and they understand the layers, and then they need a space where they can be heard. So this is me advocating for all those champions. And for all those new generational workers, telecom's where it's at, right, Francis?
Definitely.
Okay. I just called myself a character. Okay. Let's just run down based on what risks, and let's just spell it out, emerge when utilities don't fully understand these dependencies.
Well, blind
And I
spots,
guess
definitely.
dependencies, because there's a lot there I just listed, but dependencies in your telecom world, operations technology world, and then like the operations folk.
Yeah, I'll sum it up with blind spots,
Okay,
right?
blind spots.
Blind spots are, if you want to use a different word for my vocabulary, scatomas,
I
right?
like it.
So, okay, so one on one. So the transport layer, which is the telecom, and the control layer, which is your SCADA, your ADMS, your what have yous. That needs to be in sync. And if they're not in sync, that's where the blind spots come in, or your scotomas. So you mentioned part of the answer with cybersecurity. I may not have the number right, but I remember working for one of the utilities in the United States, and they were saying that at one time I was speaking to someone, and they were saying, I think more than 50 times a day, I don't remember the number, so I don't want to call a number. More than 50 times a day, they know people trying to hack into this system. Think about it like that. If some rogue person get into the telecommunication network or the control system, think about the damages they can do to that. And it's something that when, and I don't want to be too political, but when the leaders or politicians talk about it, or legislators talk about it, I guess a lot of people don't take it as serious as it could be. But let's just imagine somebody walking on a line live and some rogue person open or close something that caused that person to die. That is one less person going home at the end of the day. And I always try to tie safety in everything I do because it's so important in the industry that safety is first and foremost. So, blind spots from a cybersecurity level, from not knowing what's happening at your grid and when it happened. And then one of the things that I want to touch on is root cause analysis. When you have an issue and you really want to see what truly happened, in the industry, they call that, they do a root cause analysis, but without proper communication sometimes, making sure that what bit or what fault was asserted in a protective relay, the time that was asserted, and then how it traveled between then to report to your SCADA system or your ADMS system or whatever system that you have. All of that is as integral as resolving the issue itself. Because if you cannot get to the root cause of the problem, most time it will just be repeated, right? They'll be like, the line trip again, line XYZ tripped again. But why did it trip or why it continues to trip? That root cause is very important in order to help, and communication help that. And without the communication, that risk emerge.
I just want to interject. This root cause analysis, if you think about like where we've been, where we are, where we're going, where we ought to be, root cause analysis was really all that the industry had. I mean, if you think about the tinkering and the experimentation and the laboratories, that was a predominant part of the industry in the 1890s, maybe 1880s, maybe a little bit earlier, is to do and to see. Now, granted, like over time, we've gotten better at being safe, but up until really today, I wouldn't say there's a lot of utilities that are, but there's the capability maybe 10 years ago to unlock this ability to not just have data to drive a really accurate root cause analysis, which is very important because events will occur that are outside anyone's control. But the space that we're leading into, especially with this noise of data, is then giving information in a way that the root cause analysis is so robust with a historical backbone that it can start to predict. And I guess I just wanted to share, like, that's another enabler of the comm system. Because if you don't have the sensors and you don't have the data, you can never really build out that type of predictability to really drive, where we're all headed, having a need or desire for 99.9999% electrical power. I think that's just but root cause analyses have always been done. But like, if you're not collecting the data, it's not that it's wrong. It's just the faith and the confidence in said execution of said analyses could still have, that air of misgivings. Anyway, so I just wanted to point that out.
Yeah, in everything in life there's risk, right?
Right.
So risk will emerge. The data and the control systems, the communication system, if it's done right, will help eliminate or mitigate, not eliminate because it can be eliminated, but mitigate some of these risks.
Right. And I think, leaning towards the grid modernization realm, like what becomes dangerous is when organizations like modernize their systems independently, right? So there becomes this gray space and these ownership gaps and really misunderstanding between the teams and misunderstanding of the dependency, right? Because like planning focused on planning, telecom focused on telecom, IT focused on enterprise systems, which is like your financial, your HR, OT, operations technologies, is a very debatable word right now, but it focuses on the operational systems, aka the systems that run the grid that the planners are planning on, the telecoms are overseeing, and then I guess I missed asset management engineers are focused on their asset. So, there's a risk right there. If you don't see this full umbrella of understanding of this complex system, you can drive your organization to kind of have these gaps that really causes a large risk. And you kind of spoke to those risks in general.
The industry is changing, right? Before it was more of a siloed approach.
Not for the lack of trying, Francis.
Not for the lack of trying.
I wouldn't say we are at a steady state here.
No, we are not, but it's much better than when I started.
Yes.
I promise you.
So we are making progress for listeners. The work is happening, and it might just not be as fast as you all want it.
Yes. So it's getting better, and we continue to get better, and we continue to evolve, because I don't know of any piece of equipment today that don't have a Ethernet jack or Ethernet port or an IP port in it. I don't, while you were speaking, that's what I was thinking about. I was like, is there any device in a substation that really don't have some way or means to communicate, either wirelessly or otherwise, right? Hardwired or wireless.
I guess the question is, yes, they're out there, but anything new or something that could be added or replaced, it's available.
Right. And that's the correction. I thank you for that, because the older systems definitely have that. But since it's been upgraded, since it's brand new,
and that's a big part of this discussion is, we are all sitting with an aged infrastructure that has to transform into this new space. And a big part of this invisible backbone that we're talking about is this other layer of assets. And I guess just for our listeners, like, I continue to say assets just for anyone that, why I should keep saying that, is like, an entity owns a set of transformers and wires and circuit breakers and control rooms and control hubs. So they're like assets. And there's a subject matter expert of every one of those assets sitting within the utility. And that subject matter expert might be an expert of 20 assets. But the idea is every single one of these sets of, I feel like I can't say the name asset again, but devices. Has someone overlooking it to maintain, inspect, and determine the prioritization of when it needs to be replaced. And that becomes very complex in itself. And I guess for our listeners, you said OBG. No, you said OGW, which is your optical ground wire, which is a whole fleet of an asset. right? Then you mentioned fiber. So like fiber is a physical element that has its specifications, its ratings, its capabilities. We talked about the control house. It has its panels and its ports. You have, I'm just rattling like the sonnet system is like something of separation, of difference. And then you have, right, like all of the assets to support broadband or, Wi-Fi. And that all enables like SCADA, your relays, your synchrophasers, the ADMS system we all love to talk about, how the substations talk to each other. And I guess I'm rattling this all off as like, this isn't just like one thing. This is a complex network of things that all need to be understood and spoken for as the other layers evolve. I mean, I guess like, right, the microwave communication system, like that's like a whole, like, what is that thing? I'm just kidding. But, I mean, it's important. But like not many people are realizing utilities have to maintain the towers and the dishes and the frequency and wavelengths.
If you have your private LTE, for example, you basically your own AT&T or your own Verizon or for those in the US.
Right. I mean, then there's the legacy systems, right? Like there's still this whole copper
Right.
space. So for a telecom SME, I mean, that's what they are delegated to be designated experts over. And then you mentioned this wireless. You could have your private LTE, which more or less means you're securing or leasing or procuring your own wavelength so that you're not sharing it with your public Wi-Fi that we all know and love, Verizon, T-Mobile, AT&T. I don't know. Are those the big three?
Right.
But okay. And then I guess I mentioned land mobile radios. That's like a whole mission critical workforce communication. There's just so much to unpack here. Okay, so going back to my questions, I think we named the risks, some of them, of the gaps of understanding between telecom, OT, operations, right? So I guess let's poke a hole at that, and then we'll kind of wrap it up for this session. When you hear IT, OT convergence, like what resonates in you to like object and or confirm that this is something that should or should not be happening? Or like what does it make you think as an expert?
Definitely confirm. No objection. When you look at all that we spoke about and others, right? As I said, the mindset has shifted. There's definitely a shift in leadership. Before, when I started, and I keep, I'm getting old, so it's been a while. But when I started, that operations really did not think about, most times, did not think about the value of the communication part of it. Because most of these devices, when I started, was not even IP based, they were serial based, right? So you set up your serial communication and you're good. And as we mentioned a while ago, most of the new products are replaced, what is either being installed or being replaced in the older products. They communicate very differently. They
Now,
bring
just to make sure, because you said serial versus IP,
yes,
which means the way they were programmed and like
the way they communicated.
right. So like what you started with was serial. What has a lot have evolved to is IP, but they still both exist. And so like you didn't really have to understand the diverse communication.
Right. So in when I started, the serial communication was much easier, right? Most time it was a direct communication.
Yeah, like endpoint to endpoint.
Endpoint to endpoint. So since you configure your baud rate with your speed and your stop bit, what have you, you're golden. But now, you place that same signal through an internet protocol. So you have to now understand all the parameters within that. For example, you might have a cable, Ethernet cable going into the back of your relay, but that not only doing your communication, but is also giving you a time, right? So things like network transfer, Network Transport Protocol, NTP, and stuff like that, which is part of the TCP/IP suite. So, as I said, I cannot stress the importance more than I am doing, because it is needed, it's valid, because of you can do with one strand of one point, communication point, you can do so many different things.
That are integrated.
That is all integrated. The people, when in one of the utilities I worked for in New Jersey, they were what we call automation engineer and protection engineers. And I was on the automation side, so I used to always say we're better than the protection people, because we had to understand the protection and the communication. I'm a bit biased here to the automation engineers.
Well, I love it. Go ahead.
So you have to understand, as I was saying, not just what is overcurrent or differential or what have you, but you have to understand the why and how it's going to communicate, right? Especially when you're doing things like your line relays. You have to understand that if you're doing an underground network and you want to have some protection, whereby if there's a fire in a vault, that sends a signal back to the RTU, and then it opens all the other vaults once again, from safety, but also from a reliability perspective, because you don't want all your underground vaults be damaged, which is all, most of our cities are served by some underground infrastructure. They're not overhead, and that's why you don't see them. So you want to make sure you have all these mechanisms built in. I'll pause here. I see you.
Well, I have a dead stop in 3 minutes. So, Francis, I'm gonna wrap you up.
Dead stop in 3 minutes. So let me wrap up. So it's important. The governance is more visible, it's more understandable, and now it's from a top-down approach than just 2 or 3 voices in the room saying, we need to protect this stuff. So all in all, although it's invisible, the visibility on the inside is
a must.
Is a must.
I love that. It's the integration and bringing it to light, as we said earlier. So yeah, the IT-OT convergence, what you're saying, it's really less about, and I guess this is me coming to you, but like organizational structures and charts. It's more about operational alignment. And so, there was a world where these were separate, but the idea of the convergence is necessary because of the diversity and complexity of all of the systems that you just spoke of, like integrate with each other. So, and the convergence might sound simple on paper, but it truly is complex when you start putting the practice together, because now you're dealing with not the true technology, it's the people and the processes and the platforms that they all sat on, and now they're coming together, and there's the ownership and the gap and the conversation. So like everything we talked about is like less about the words and more about like what's behind it and the complexity that must be delivered. So like with this episode, I think we brought to light the varying parts and the importance of really bringing these conversations and these understandings to really all, so that when they're sitting at the tables in their different chairs, they understand this holistic perspective. And I think that's really what you and I really drive for when we keep showing up on the Grid Mod Pod. So I want to thank you again for being my telecom expert, bringing telecom to light, and I look forward to our future conversations together. And so with that, till next time.
Yeah, thank you. It's always an honor, and I'm looking forward to the next one. Let's get it done. Bye-bye.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode next week. Until then, keep powering on.